Look up at the night sky on a clear, dark night, and you might see a faint smudge of light stretching across the stars. That pale band is the Milky Way, the galaxy that contains our Sun, our solar system, and hundreds of billions of other stars. It feels enormous, almost unimaginably vast. From one edge to the other, the Milky Way stretches about 100,000 light-years across. Inside it orbits somewhere between 200 and 400 billion stars, along with clouds of gas, dust, and mysterious dark matter. For most of human history, we believed this galaxy was the entire universe. But today, we know something far more astonishing. The Milky Way is just one galaxy among trillions. And one of those galaxies, our closest giant neighbor, is slowly moving toward us. Its name is Andromeda, and one day, the Milky Way and Andromeda will collide. Not tomorrow, not next year, but in about 4 billion years, the two largest galaxies in our local region of space will begin one of the most spectacular cosmic events imaginable, a galactic crash involving hundreds of billions of stars. A collision that will reshape the entire night sky, and ultimately create an entirely new galaxy. But here's the strange part. When galaxies collide, they don't behave the way you might expect, because galaxies are mostly empty space. To understand what will actually happen, we need to start with the scale of galaxies themselves. Imagine shrinking the Milky Way so that it is the size of North America. At that scale, each star would be roughly the size of a grain of sand. And the distance between those grains would be thousands of kilometers. Even in the dense regions of galaxies, stars are incredibly far apart. So when galaxies pass through each other, direct collisions between stars are extremely rare. Instead, the real drama happens through gravity. And gravity on a galactic scale is unimaginably powerful. Right now, the Andromeda galaxy is about 2.5 million light-years away from us. That distance sounds enormous, but in cosmic terms, it's relatively close. Andromeda is already moving toward the Milky Way at about 110 kilometers per second. That's over 400,000 kilometers per hour. At that speed, the two galaxies are slowly, but inevitably falling toward one another. Astronomers have known about this motion for more than a century. Spectroscopic measurements show that Andromeda's light is slightly blue-shifted, meaning it is moving toward us rather than away. Most galaxies in the universe are receding due to cosmic expansion. But gravity between the Milky Way and Andromeda is strong enough to overcome that expansion. And so the two galaxies are on a collision course. But this collision will not happen suddenly. It will unfold over billions of years. The first stage will begin roughly 4 billion years from now. At that time, Andromeda will loom enormous in the sky. From Earth, if Earth still exists, it will appear many times larger than the Moon. Its spiral arms will stretch across the heavens like a glowing river of stars. As the galaxies draw closer, their gravitational fields will begin to distort each other. Stars will be pulled into enormous tidal streams, clouds of gas will collide and compress. New waves of star formation will ignite across both galaxies. Massive clusters of newborn stars will blaze into existence, then comes the first real encounter. The galaxies will begin to pass through one another, not once, but several times. Their shapes will stretch and twist under the immense pull of gravity. Spiral arms will tear apart, long ribbons of stars will arc out into space. The structure of both galaxies will become chaotic. Imagine two enormous whirlpools colliding in slow motion. That's roughly what this process will look like, except each whirlpool contains hundreds of billions of stars. Despite the violence of the event, the chance that our Sun will collide with another star is extremely small. In fact, astronomers estimate the probability of a direct stellar collision during the merger to be less than 1 in a trillion. The distances between stars are simply too large. But gravitational encounters will still have dramatic effects. Stars will be flung into new orbits, some may be ejected entirely into intergalactic space. Others will fall toward the center of the merging galaxies. And at the core of both galaxies lies something even more extreme. A supermassive black hole. At the center of the Milky Way sits a black hole called Sagittarius A*. It contains about 4 million times the mass of the Sun. Andromeda also hosts a massive black hole, even larger. As the galaxies merge, these two gravitational giants will eventually spiral toward one another. Over millions of years, they will dance closer and closer together. Finally, they will collide and merge into a single, even larger black hole. When that happens, the event will release enormous gravitational waves rippling across space. Far future civilizations, if any exist, might detect those waves as echoes of the galactic collision. Meanwhile, the galaxies themselves will continue to settle. After several passes through each other, gravity will gradually pull the stars into a new stable structure. The graceful spiral shapes of both galaxies will be destroyed. In their place will form a giant elliptical galaxy. Astronomers have already given this future galaxy a nickname, Milkomeda, a combination of the Milky Way and Andromeda. Milkomeda will contain roughly 1 trillion stars, twice as many as either galaxy today. It will be larger, brighter, and far more massive. But by that time, the night sky will look completely different. The familiar band of the Milky Way will be gone. Instead, the sky will be filled with dense clusters of stars. New constellations will form. Old ones will vanish. Massive streams of stars may arc across the sky like glowing bridges. And somewhere within that newly formed galaxy, our sun may still exist. Or it may have been flung outward into the galaxy's halo. There is even a small chance the solar system could be ejected into deep intergalactic space. But the most important detail of this cosmic story is timing. The Milky Way-Andromeda collision will not happen for billions of years. By that time, our own sun will be nearing the end of its life. In about 5 billion years, the sun will expand into a red giant. Its outer layers will swell outward, possibly engulfing Mercury, Venus, and perhaps even Earth. Long before the galactic collision reaches its final stage, the inner solar system may already be uninhabitable. Humanity, if it still exists, will likely have moved far beyond Earth, perhaps to distant star systems, perhaps to other galaxies. But the cosmic dance between the Milky Way and Andromeda will continue regardless. Two enormous galaxies slowly merging under the influence of gravity. A process unfolding on a scale so vast that it makes human history seem like the blink of an eye. When we look up at the night sky today, the Andromeda galaxy appears as a faint blur barely visible to the naked eye. But that faint blur is actually an entire galaxy racing toward us, containing hundreds of billions of stars, and one day, far in the future, it will become part of our own. The universe is constantly changing. Stars are born, galaxies collide. And even the largest structures in the cosmos evolve over time. The Milky Way and Andromeda are not permanent fixtures of the universe. They are participants in a long cosmic story. A story that will eventually reshape the entire galaxy we call home. And every time you look up at the night sky, you are witnessing the early chapter of that story. Because somewhere out there, across millions of light years of space, a giant galaxy is already on its way toward us, slowly, inevitably. And when the two finally meet, the night sky will never look the same again. If you enjoy exploring the strange and fascinating events shaping our universe, subscribe to the channel and join us for more journeys through the cosmos.